Hello, George Hepworth, Grover Park Consulting. Welcome back to the Northwind Developer PowerApps series. In this video, we're returning to the PowerApps environment to show how the application interacts with SQL Server stored procedures. We've spent the last few videos on the SQL Server side covering the CRUD stored procedures for order details. Now, let's see how those procedures get triggered inside PowerApps, reusably, efficiently, and in a centralized way. Here is the screen that drives most of our procedure calls. It's called scrAppCode. It contains a series of toggle buttons, each tied to a master stored procedure. Most of them are the CRUD master procedures, but there are others. You can think of this screen as our low-code command center. Instead of copying logic to every screen, we send requests for data here. It's a powerful reusability pattern, a centralized location, somewhat like a standard code module, containing multiple functions and subs. Full disclosure, I did not invent this method. I adapted and expanded it for this application from an example I found on YouTube a few years ago. I kept it in my back pocket for an application like this, and it has really paid off. Before I get into the details here, I want to review global and local variables because you'll see both in PowerApps. Global variables retain their value across different screens in an application. Local variables are only available within an active screen where they are created, just like local variables inside a VBA procedure. When the screen is no longer active, local variables lose their values. You'll see how that influences our code shortly. Access developers already understand the importance of global or public variables and local variables. You'll see them here. It's important because the way we use stored procedures in a central screen location depends on having both global and local variables. The content we retrieve from SQL Server doesn't need to hang around in memory after we're done with it. That's where local variables come into play. I use the prefixes GV and LV for the two types of variables. Next, let's walk through the Add, Select, Edit, Order Detail toggle. Toggle buttons have a default value controlled by a global variable. For this toggle button, the global variable is TGL CRUD Order Detail. If the value of this variable changes anywhere in the application, even on another screen, it changes here. That causes the onChange event to fire, and more on how we do that later. A local variable could not do that for us. Here's the core of the onChange event. We use the update context method to create a local variable and assign to it the contents of the response we get back from a stored procedure. In a previous video, I pointed out that variables in PowerApps can contain anything from a single data point to an entire record set or a table. In this case, the variable will contain the entire content of the response from the stored procedure. That can include one or more output parameters, one or more results sets, and a return code. We don't always use all three, but they're always available. If you think about it, the reason we would use a local variable for this is that we don't want to clog up memory by stuffing a lot of global variables into it. Once we get the pieces we need from the stored procedure response, we can throw the rest away. On the other hand, we can take advantage of those components to handle the response comprehensively in a single event. Specifically, LV, local variable, CRUD order detail, receives the contents of the response from the master stored procedure CRUD order detail. I think I mentioned previously that PowerApps puts the schema in front of the procedure name, just like we've always seen in Access with linked server tables. We pass it a flag telling it what kind of operation we want to run. This is a global variable set when we call this stored procedure. It tells us create, read, update, or delete. Here we're defaulting to read on the basis of do no harm. If everything else goes wrong, all we're going to do is read the records back and not modify any of them in the table. We need to tell it the order ID. If we're updating an existing order detail record, we'll pass it the primary key of the order detail record. The product being added to an order detail, the quantity, any discount, unit price, and the order detail status. This code sets the results returned by the stored procedure to a local variable, LV CRUD order detail, which has no meaning anywhere else in the app, subject to a qualification that I will come back to later. All procedure parameters use default values, including the CRUD type. We explained in a previous video that setting defaults, typically to 0 or null, enables us to select all or none of that parameter, making each more flexible. Next, we evaluate the error code. This is our standard error handler. We always get back a set of output parameters, one or more output parameters, which includes an error code. If it comes back as something other than 0, that indicates an error occurred. We notify the user by concatenating the error code together with the message that came back through the output parameter for error messages. We display an error type notification, and we display that for a standard length of time. These output values, error code and message, come from the custom error message procedure we covered in the last video. Custom error message translates system error codes into user-friendly messages within a context, improving clarity for the end user. This section of code is required to manage the interface. Depending on the results we got back, we want certain interface items to be set or reset, visible or enabled, and so on. In the next session, we determine whether or not we need to update the named formula for order details. I explained named formulas in a previous video. This is a in-memory record set containing all of the current records in the table, in this case order details, with all of their current values. If we have updated an existing record, created a new record, or deleted a record, the in-memory result set in F order details will be out of sync with the order detail records. We need to refresh our in-memory table to match. Explicitly clearing the value of the local variable LV CRUD order detail is necessary because of the non-standard way I implemented this common code design. In order for other screens to reach its code, this screen has to remain active, even when not visible to the user. That's offset, unfortunately, by the fact that local variables created in the app code screen are never closed or released because their host screen doesn't close. I have to do it manually in order to keep memory uncluttered. This approach allows us to reuse a stored procedure in more than one place. There is the matter of repeating the parameters, of course, every time we call it, but that's something that couldn't be avoided in any case. The toggles both run the procedure and refresh results in one pass. We don't want to duplicate the on-change logic everywhere. Instead, we trigger the toggle remotely. Let's look at that next. Here's a command button on the order form. It adds order details. Here's the code behind that buttons on select event. We have a series of set commands to create global variables for each of the parameters we're going to need when we run that stored procedure. CRUD type is going to be create. The order ID is the current order ID of the parent to the order detail we're going to add. If there's a discount applied, that will go into the GV discount, order detail status, the product that we're going to add, quantity, unit price. We set variables for all of the parameters that need to be passed back to the stored procedure. Then we toggle the value. We toggle the value of the global variable, GV, TGL, CRUD order detail, from true to false or false to true. Notice that there is no logic, data update, nothing here except setting the values for the stored parameters and toggling the value of the variable which causes the toggles on change event to run. This is the PowerApps equivalent of calling a subroutine in VBA. You can use this pattern. I, in fact, did use this pattern throughout this application. All it requires is a matching variable and hidden control that links that variable to a toggle. Let's call it what it is. Modular architecture in a low-code world. Instead of repeating code or wiring up forms directly to SQL tables, we use global variables to pass parameters. We centralize logic in one location, scrAppCode. We fire reusable toggles to execute reusable CRUD operations. We show feedback and refresh UI elements consistently. It's clean, it's structured, and it's scalable. For Access developers, this feels a lot like calling centralized VBA functions with arguments passed in. That's how we fire SQL Server stored procedures from PowerApps using a toggle-driven model. It may seem unconventional at first to many low-code PowerApps developers, but the reusability and the clarity it brings to the app is worth learning. In upcoming videos, we'll look at the same pattern for other entities like purchase orders or companies or employees. Some of the other stored procedures we'll look at fall under a category that I think of as helper stored procedures. We'll look at those in later videos also. So thanks for watching. If you found this useful, like, subscribe, and keep experimenting. I'll see you next time.